Hello dear students. Today I'm explaining something that will help you for the lab of the week 5. Let's begin by what is the atom and what are the valence electrons. Well, everybody knows that an atom is made of the nucleus where we find the protons that are positive and the neutrons, the blue ones, that are neutral. And around this nucleus, we have empty space where we can find the electrons in orbits spinning around the nucleus. The outermost shells are what we call the valence electrons and are the most important ones in chemistry, because are the ones that take part of the chemical reactions. So let's focus on the valence electrons that are the outermost electron shell of an atom. Look at this. In the first shell, we can have only 2 electrons. In the second shell, we can have 8 electrons. In the third one, 18 electrons. And in the last one, 32 electrons. Let's see the configuration of helium. Well, helium is a noble gas, as the 2 electrons that helium has are in the same orbit, and this orbit only allows 2 electrons. We can say that helium is stable. Helium doesn't need to gain electrons or to lose electrons to be stable, because for helium, that is period 1, only 2 electrons are allowed in this shell. But if you go to lithium, lithium has 3 electrons, then has the same 2 electrons in the first shell, but also have an extra one in the second shell. Is lithium stable? No, it's very reactive. Then lithium prefers to lose these electrons and get the configuration of helium that has 2 electrons in the outermost shell. Here you have sodium. Well, sodium has only 1 electron in the outermost shell. And if sodium loses this electron, look at this, 1, 2, 3, 4, 5, 6, 7, 8 electrons will be in the outermost shell when sodium loses this electron that is alone here. And now has a configuration of a noble gas that has 8 electrons in the outermost shell and is stable. Well, then the noble gases are very, very important because they have stability. They don't react. They don't need to lose or gain electrons. They are stable because they have 2 electrons for helium and 8 electrons for the rest of the atoms in the outermost shell. That's what we call noble gas configuration, to have 8 electrons in the outermost shell. Look at this. Helium, 2 electrons, is super good. Neon, 8 electrons in the outermost shell, super good. Argon, 8 electrons in the outermost shell, super good. They are stable. Well, sodium has one electron in the outermost shell. Then if sodium loses this electron, we'll get the neon configuration that has an electron in the outermost shell. So sodium used to lose electrons to make the cation +1, because loses one electron, then has an extra positive charge, and this is what makes sodium so reactive. Magnesium is in the group 2, so it has 2 electrons in the outermost shell. That's why magnesium uses to lose 2 electrons to get the neon configuration, that is 2 and 8. 8 is the number that gives stability to magnesium when it loses 2 electrons. And I represent these 2 electrons loses as these 2 pieces that are missing here in this rectangle. This is the way that I represent magnesium. Look, 1 electron, 2 electrons that are missing, and then magnesium is +2. Aluminum loses 3 electrons, then I make 1 electron, 2 electrons, 3 electrons. But chlorine needs an extra electron. It's easier for chlorine to gain 1 electron and get 8 electrons. That's why chlorine gains 1 electron, and then I make this figure. Oxygen needs 2 electrons because it has only 6 electrons, then need to gain 2 electrons and make the oxide ion to get the noble gas configuration. That's why I put these 2 forms here, because sodium, sorry, it's a mistake here. Then let me draw the right one, sorry. Look, this is oxygen, and oxygen needs 1 and 2 electrons to get this is incorrect, to get the noble gas configuration. Needs, look, 1, 2 electrons, and makes the oxide ion that has an electron in the outermost shell and is like neon stable. Chlorine needs only 1 electron. Look, only 1 electron gain. Oh, and sodium loses 1 electron. That's why they fix. Sodium give the electrons, chlorine gain the electrons, and then they make sodium chloride. Sodium chloride. Here you have calcium used to lose 1 electron, 2 electrons, loses calcium to get the noble gas configuration. That's why if chlorine gains 1 electron, then this chlorine will take this electron, and this chlorine will take the second electron, and now they make calcium chloride. As we need 2 chlorides, we have to put the 2 into here as a subscript. But what happened in a cation that used to lose 2 electrons, 1 and 2 electrons, and an ion that needs 1, 2, 3 electrons? How we can fix it? Well, we begin trying to make this cation to give 1 and 2 electrons. But this anion needs an extra 1. then it will take this electron from this cation, and now there is an extra cation here, extra electron here. We get another anion that will take this electron plus the 2 electrons from other cation. That's why in this case we need, this is a cation, we need 3 cation and only 2 anion to make this compound that I represented this way. In the lab, what I wanted you is to represent compounds using this configuration. That is a simple one, but it makes you to know how many electrons are gained by the anions and how many electrons are lost by the cations. I hope that you understand right now. Anyway, if you have any question, ask me. Don't hesitate.